Well, hi, I'm here to help you out with, in section 4.5, this is problem 4.59, and this problem has to do with how to neutralize a solution of calcium hydroxide with some rather dilute looking 0.001 molar hydrochloric acid. So I'll just kind of get us right into this. The information that we're told is that the solubility of calcium hydroxide in water is 0.185 grams for every 100 mils. And you know what that means is that you can't dissolve any more than 0.185 grams of calcium hydroxide in 100 mils. So that would be a saturated solution. Now in this problem we're told that we only have 10 mils of that solution. So my initial calculation says, well, if I had 0.185 grams in 100 mils, I must have a tenth of that in 10 mils, so that would be 0.0185 grams of calcium hydroxide in that solution. Now you can well imagine that what's going to be pretty important in this is that I have, I'll have to find out how many moles of calcium hydroxide I have so that I can figure out how many moles of hydrochloric acid I have to use to neutralize that. So there's a couple of equations that are going to be pretty important. This one here, this is the solute equation. That's the number of moles is equal to a concentration times volume. That's for solutes. And this is another one. This is if I have a pure substance. The number of moles would be the mass of a substance divided by its molar mass, typically grams over grams per mole. So in this case, I think that this is the relevant equation. That is to say, I know I have 0.0185 grams of calcium hydroxide in that solution. And I know the molar mass, I looked it up already, it's, of calcium hydroxide is 74.1 grams per mole. So this looks like the right equation. So if you want, pause and why don't you get the number of moles of calcium hydroxide that are in those 10 mils. Okay, that's pretty straightforward. I think N is equal to mass divided by the molar mass. That's the mass, and I will divide it by the molar mass, 0.0185 divided by 74, and I've already calculated that. That's 2.5 times 10 to the minus 4 moles of calcium hydroxide. If I wanted to convert that into millimoles, then I would say, oh, I just get to multiply that by 1,000, so that looks like 0.25 millimoles of calcium hydroxide. Yeah, okay. So that's the number of moles of calcium hydroxide. Now the next step, as you well know, is I need to think about a neutralization reaction. And I've sort of laid out the bare bones here. I know that, typically the case is acid plus a base. HCl is the acid, calcium hydroxide is the base. React to form a salt and a water. So I've taken the anion for the acid and paired that up with the calcium to make the salt. And then the H and the OH minus, H plus and OH minus will make the water. So if you want, why don't you pause it and balance this reaction. Okay. I know that there's 2 OH minuses for every calcium. Calcium is an alkaline earth metal, so I've got that. That means if I have 2 chlorides, then I better have 2 HCl's, and if I have 2 HCl's, then I need 2 H2O's. Good? Okay. Let's see. I think we're almost done here. I need to figure out how many moles of HCl I'm going to need to neutralize 0.25 millimoles of calcium hydroxide, and I'm seeing that there's a 2-to-1 ratio. Well, okay, that means the number of moles of HCl must obviously be twice that number, so I'm looking at 0.5 millimoles of HCl. That's how much I need to add to neutralize that much calcium hydroxide. So the last step on this is to figure out how much volume of this rather dilute HCl solution is needed to deliver a half a millimole, and well, that's where this equation will come in. That needs to be a half a millimole, so I'll solve that for the volume. I guess I better put it down here. The volume of the HCl will have to be equal to N divided by C. That is the number of moles of HCl, 0.5, divided by the concentration of the HCl. We already said that that's 0.001, 001, and because that's millimoles divided by moles per liter, then the answer is in milliliters, and it comes out to be 500 milliliters of our HCl solution, and that's our answer.